Welcome back. Let's look at how to write condensed electronic configuration before moving on to writing boxed electronic configuration. Okay. The reason I chose that is because condensed electronic configuration is very much easier, and I think it probably is better to study that before we move on to the boxed electronic configuration, right? So that's the title. And first, you got to follow all the rules we have established earlier, whether it's an element or a cation or anion. You've got to follow all the rules. Make sure whether you're following the rules for domain 1 or domain 2. Okay. So first, you've got to get the correct electronic configuration. That's key. Second, find out where the element is on the periodic table. That's not very hard. Find out what noble gas is present in a row ahead of the row containing the element under question. Let's say the element that we are focusing is potassium. Then the noble gas present in a row prior to the row containing potassium is argon. Okay. Now this has no bearing on rule A. Now you could do C perfectly fine, but if you didn't have A correctly done, chances are you're never going to get the whole question right. So as I said, chemistry is a collection of interconnected objects. While it may appear as if the two rules is independent of each other, when you put them together, it becomes connected. All right. So question C is interrelated to rule C is interrelated to rule A. All right. So argon is part of the 3p window. Now, I'm going to put a placeholder for D for now. Let's actually, do the problem. Okay, I'm going to put all of this, assuming if you had paused the video or you didn't, that you end up, this is the correct electronic configuration. Okay, potassium is in row 4, so you should have applied domain 2 rules to establish the correct electronic configuration. Now we have the correct electronic configuration. Now let's apply rule D. That's why I didn't even bother reading rule 3, because it doesn't make any sense without an actual image or something to look at it. All right. So argon, okay, if you go back to that flow chart, the map I gave you, argon is part of the 3p window. If you see, I put it this way, argon is at the very end, right? Now, that means you can strike off everything that is up to 3p. We don't need that. Okay? And that's what I mean by argon is part of the 3p window. So write AR within square brackets followed by orbitals in the sequence that appear after 3p, right? So once you identified argon is part of the 3p band, you can start striking off up until 3p and write AR in square brackets and then write whatever's left. It's 4s2. In this case, it's 4s2. In some other case, it could be something else. Okay. You can see I have the correct condensed electronic configuration, which is AR4s2. Okay. Now, I'm going to go to the next screen, and I might only work out one example because the condensed electronic configuration is kind of summarizing your entire understanding of you being able to write an electronic configuration. Okay, so I don't need to do 10 other things. Okay, it's basically rule D is essentially what makes a condensed electronic configuration, and I've explained it. All right. So let me do it for strontium 2+. Okay. Now, if you go back and look at the periodic table or the chart I have given you, strontium is in row 5, right? So follow the sequence first and write the electronic configuration of strontium first. So it's 1s2, 1s, 2s, 2p, 3s, 3p, 4s, 3D, 4p, 5s, and then 4D. I guess we can stop 5s. That's where strontium is part of the 5s band, right? So let's start filling 2, 2, 6, 2, 6, 2, 10, 6, stop. At this moment, you got to count. So 10, and then again 10, 20, 30, 36, and strontium is 38. So what did I say? 10, 20, 30, 36. So you say 2. This is strontium. Strontium 2 plus means we have lost 2 electrons, right? So that means it's 1s2, 2s2, means we lose both these electrons. So the outermost is what is lost. So 3s2, 3p6, 4s2, 3d10. Now, did we have it right? Well, I shouldn't have removed it, but I guess in this case it doesn't matter. But you should be very careful. This is not complete yet, right? I should have done it prior, but you can excuse me this time because I don't think it would have mattered. But you need to make sure that you switch before you take out electrons. But again, because 5p is independent, it would have had no effect. Now, this is the correct electronic configuration, right, for SR2+. Now, SR2+ is in a row, and the Nobel gas before that is Kr, right? But Kr is already part of the 4p window, right? So if you strike out everything up to 4p, there's nothing left. So all you have to say is SR2+'s condensed electronic configuration is just Ar. Sorry, Kr. Okay. Does that make sense? So try these, okay, and then you can ask me questions. All right, and this is how you write condensed electronic configuration, right? Just rule D is an added aspect to your already existing knowledge of how to write electronic configuration, okay? All right, well, that's condensed electronic configuration for you, and I'll see you back with boxed electronic configuration.